Welcome you all the lecture series of operating system. In this video, the topic we are going to see is classical problems of process synchronization. So the process synchronization solution is two types. One is a hardware based, other one is a software based. So in the previous video, we have seen the software based solution of Peterson solution. So next is the hardware based solution. We are having a locking solution and also using the semaphore these are all the two main hardware based solution. Yeah, what is semaphore? Semaphore is nothing but it's a synchronization tool that provides the more sophisticated ways that is using the mutex locks for a process to synchronize their activities. So the semaphore S is an integer variable. It can only be accessed via the two indivisible, that is, and two atomic operations of wait and signal, originally called the P and V. The definition of wait operation means we have to wait while S is equal to 0. S is less than or equal to 0. So what do you mean by S is equal to 0 means, so the process of P1 is want to use the critical section means that semaphore value is equal to 0 means that could not enter into the critical section. So those process semaphore value S is equal to 1 means that process is enter into the critical section. So while S is less than or equal to 0, we cannot enter into the critical section, we have to wait. After that, so after that we are going to increase the S value, then we can use the critical section code. After using the critical section code, we can automatically decrement the S value. So that is a wait operation. So what is a signal operation means, the signal of S is equal to when the process is completing, for example the process is completing that execution, that process S value should be equal to 1. So the process initially it is initialized to 0. After it incrementing S is equal to 1, that process is entered into the critical section. So this is a semaphore usage of using that process synchronization. So in the semaphore we are having a two types. One is a counting semaphore, other one is a binary semaphore. For example, in that semaphore, we are using that two thing. One is a wait and signal. So, for example, the process P1 that is in the S1 means that is in the but that is using that signal means, so the signal after S1 is completing its critical section, it give the signal to the other process. So now the P2, once the S1 is using, the P2 is in the waiting state. So the P2 code, it have the wait of sync. After completing S1, the S2 is used the critical section. So this is the code of two processes. So the classical problems of synchronization, we have three types of problems. One is a bounded buffer problem, other one is a readers writers problem, then dining philosopher problem. So the solution to the bounded buffer problem using that semaphore is that we are using the common sharing variable is buffer. Here is the code of, we are using only the one mutex variable of yum, that is a binary semaphore. So is used to acquire or release the lock. Next is the empty is counting semaphore whose initial value is the number of slots in the buffer, since initially the all slots are empty. A number of slots in the buffer. Next is that full means counting semaphore whose initial value is 0. So the full is equal to 0 means number of filled slot, and empty is used to find out number of empty slots. So initially the value of semaphore is equal to 1. So here this you are having the two set of code is producer and consumer. So the producer produce an item. So after produce an item, now the initial value of empty, which is equal to n. So n is the size of the buffer. So n is empty is equal to 8. So down 8, the value of empty is equal to 7, because you are going to produce an item. Next down yes also. So down S means we are increasing the value of S is equal to 1. Now the S is equal to 0. So after it down the value of S, that producer process use the buffer item. So the buffer of N we are storing the item. After that we are incrementing the pointer variable in the buffer. So in is the point out the next free slot in the buffer. So after using the two set of critical code, next it up the value of S. So the value of S is now from S is equal to 0 to S is equal to 1. So next is up the value of full. So the finally initially the value of full is equal to 0. Now the value of full is equal to 1. That means here only one item in the buffer. So the full is used to indicate the filled slots, and empty is used to indicate the empty slots. Next is the consumer. So in the consumer code we have to down the full and down the yes. First is a we have that consumer should consume the item. So it down the full means now the full is equal to 1. So the value of full is equal to 0, and down the yes means s is equal to 1. Now the value of s is equal to 0. So after it decrementing the value of s, it goes to that buffer region. It is a critical region. So the buffer out, so the value from that buffer is stored in the item C, and next the output pointer is incremented to the next level. So after that we are incrementing the value of S and also incrementing the value of empty here. Now we see that in the producer we are incrementing the value of full after producing an item. In the consumer side we are incrementing the value of empty after consuming the item in the corresponding buffer. So this is the solution of producer consumer problem using the semaphore concept. So while using that producer consumer, here buffer is the common space. Here you are using that variable as in and out, and also two function of empty and full, and also one semaphore variable that value is either 1 or 0. I hope you will understand how to solve the producer consumer problem using the semaphore. Thank you.